Time for some calculus integration. We're going to do some integrals here. The student asked me to solve this problem right here. X times the square root of x squared plus a squared. All right, I think they gave me a letter that wasn't A. It was some Greek letter that kind of looked like an A to me, so I'm just using an A. All right, we have to start over here. We have to simplify this so that we can make it manageable. And we're going to say u is equal to x squared plus a. So we're going to get rid of the x squared plus a for the time being and just call it a u. And then we're going to take the derivative of u. So that's what this du over dx is, the derivative of u. And when you take the derivative of x squared plus a squared, it's just 2x. Because the derivative of x squared is 2x and the derivative of a squared is just a constant. Say a is 4, a squared is 16, and the derivative of 16 is 1. So, or it's nothing, sorry, the derivative of a constant is 0, my bad. So it's just 2x here. So you got du over dx equals 2x. Now we're just going to do a little bit of algebra to solve for du. I'm sorry, dx. We want to get dx by itself. We want to solve for dx. And the reason we're doing that is because we want to substitute in for this dx here in our original problem. All right, so how do we get rid of that, or how do we solve for the dx? We have to get the dx in the numerator, so we multiply it to the other side. That's what I did here. And then you divide the 2x to the other side. Now we know that dx is equal to du over 2x, and we can substitute that back into our original problem. So this is our original problem, just substituting in a u for x squared plus a squared and substituting in a du over 2x for dx. Now we can multiply some of this together. The x times the du over dx, the x's are going to cancel out. Whenever you multiply fractions, you can cancel out the numerator and the denominator if they're the same. So x times du over dx is, the x's are gone, you're just left with du over 2. So that's what I have here. Now, we want to get rid of that 2. It's actually in the denominator, so it's a 1/2, so we just pull it out front. And that's just something I remember that you can do. You can take the constant out like that. I can't really explain why, I'm sorry, but I remember you can do that. All right, so now we have something that's a little bit more manageable. Now we can try and take the derivative of the integral of the square root of u. We can just forget about the 1/2 for now. We'll bring that back in later. So we're going to take the derivative of u to the 1/2. Basically, a square root is a 1/2 power. So again, trying to do that is going to be messy, so we're going to get rid of the 1/2 and just call it n. So that's what I wrote over here. N is equal to 1/2. So this is, instead of u to the 1/2 power, it's u to the n power, which is 1/2. And now we're going to take the integral of that. When you take the integral of something, you add 1 to the power, so that's n plus 1, and then you multiply by 1 over n plus 1. So that's what I've done here. I've added 1 to n, and then I've multiplied by 1 over n plus 1, just like, well, that's the power rule for integrals, so hopefully you understand that part. And then you multiply these two together, and then you just basically have u to the n plus 1 in the numerator and n plus 1 in the denominator. And that's the integral of u to the n. All right, now we're going to substitute back into, we just solved the integral, we're going to substitute back in for n. So this becomes u to the 1/2 plus 1 instead of u to the n plus 1. And on the bottom, it's 1/2 plus 1. So the numerator is 3/2 for an exponent, because 1/2 plus 1 is 3/2, and the bottom is just a regular old 3/2. So we're taking u to the 3/2 and dividing it by 3 over 2, which when you divide, you can keep, change, flip. You can multiply by the reciprocal. So instead of dividing by 3 over 2, we're going to multiply by 2 over 3. So the 2 goes into the numerator and the 3 goes into the denominator. And this is the integral of our original problem. Now we just have to put in we have to get rid of the u and put in the x squared plus a squared. So well, I need to go to another slate, but before I do that, let me tell you where I'm going to go to. I am going to go to this step right here, because remember, there's a 1/2 in front of all this. So we got to go back to this step right here. So that's what I've written down. We're starting with that step right there. So we just took the integral of the square root of u, and we got 2u to the 3/2 over 3. That's what that whole first slate was doing, was taking the integral of the square root of u du, and you get this, and don't forget it's all multiplied by 1/2, so when you multiply these two fractions together, your 2's cancel out, and you're left with u to the 3/2 over 3. And now you can substitute in for the u. The u is the x squared plus a squared. So that's your answer. If you just had to find the derivative and it wasn't a definitive derivative, if you didn't have to substitute in for the x values, you'd be done, but you do have to substitute in for the x values. You have to substitute in an a as the upper limit and a 0 as the lower limit, or bound, whatever you like to call them. And then you subtract. You subtract the upper bound minus the lower bound. So that's what I'm doing over here. All right, so over here, you substitute in the upper bound, which is a, for your x value. So you get a squared. Everything else is the same. This is your answer, and you're just substituting in an a for the x, and then you're subtracting this thing with a 0 in for the x. Well, if you put a 0 in for x, the x goes away. So that's why this is just a squared to the 3/2 over 3, because the x squared is gone, and this x squared becomes an a squared. So now we start just doing some algebra and simplifying this. You can add your like terms together to get 2 a squareds. And you can simplify your exponents. When you have an exponent raised to another power, you multiply those exponents together. And 2 times 2/3 is 6 over 2, which is 3. That's how this a cubed gets there, is 2 times 3/2. All right, and then this parenthesis raised to the 3/2, you have to raise each one of these terms to the 3/2. The 2 gets raised to the 3/2, and the a squared gets raised to the 3/2. So 2 to the 3/2 is just 2 to the 3/2. A squared to the 3/2 is a cubed, just like we did here. 2 times 3/2 is 6 over 2, which is 3. And you're subtracting those two. You have a common denominator, so you can just use one common denominator, and you subtract the 2, and I kind of skipped the step here. I already factored out the a cubed, but basically your numerator would be this whole thing minus that, and you can factor out an a cubed from that. So let me write that down. 2 to the 3/2 a cubed minus a cubed over 3. That's the step in between here that I skipped. You combine this into one fraction. You subtract your numerators and you make a common denominator. And now you have two terms on the top. This whole thing minus a cubed, and in each term you have an a cubed. So I pulled out an a cubed, and that's how I got this. A cubed times 2 to the 3/2 gets you right back here, and a cubed times 1 gets you right there. So that's factoring out an a cubed, and that's it. That's as far as you can factor it. That's your answer, people. If you want to get rid of the 3/2 and just make it a square root, 2 to the 3/2 is the same thing as 2 cubed, the square root of 2 cubed. And when you do a square root, you don't really need the 2, and 2 cubed is 8. So that's equal to the square root of 8. So if you want to not use 2 to the 3/2, you can do the square root of 8, put a square root of 8 in there, but then you can't simplify it any further than that. So that's it. That's what I come up with. Now, unfortunately, I don't know how to check this, so I can't say for 100% certainty that it's right, but I'm pretty sure. And if it's not right, it's close enough, I think, that you'd be happy with that answer. So hopefully that helped.